Welcome back to the channel. It's been a very long time we have not met, but finally I have came with something interesting for data engineers. So in this video we will make a mini ETL project for better understanding of end-to-end pipeline. Actually, I was also very excited for this project because when I made up my mind to start this, like I was in a bit confusion that how to start with some projects, because projects are the source where we can learn from end to end, and for data engineers especially ETL is one of the most important thing. If someone is learning or if he knows about this Python Pyspark technology, it's been very frequently used in this ETL and ELT things. So let's start without wasting the time. So before starting, I will just tell you like how I have set up the tables and what are the source tables we are gonna use, which type of database it is, like from our where's which softwares, which tools we are using here. So let's begin with these things. I will already I have already mentioned in the starting of this conversation that it is a ETL project. So here we will do some and I will brief what exactly ETL works and how it exactly ETL works in that scenario. So ETL is basically defined as an extract, transform and load. So it is extracting from some source. Source means like the table. It may be table, it may be any cloud path like Amazon S3 or somewhere else. It may be some HDFS Hadoop path. So here we have tables as in source, and source type is like it's a table thing. As I mentioned, we are using table, so it is a table. But in other cases it may be files, it may be like some Parquet files, it with different formats also. It may be CSV, JSON, anything. So here we have like table, and let's understand from starting. And again now we are coming to transform. So the data we are extracting from the source, which is our table, and when we are writing those transformation through the mid stack, which is called like Python PySpark, SQL, and Spark SQL is also. So here we will do the transformation, and any operation whatever we want to do as per the requirement of the project, we will go with that scenario only. So again, when we have already transformed those data using those tech stacks like Python, PySpark, SQL, Spark SQL, we need to load those data, and those data needs to be loaded in the way that we can get the exact output or information whatever we want. So here in this project we will do the same thing for an ETL project. It's a very mini ETL project. I have named it as it's a very basic project. So for any beginners who want to take or who want to take some learning or want to do some projects end to end, they can do it. And I will just show you each and every single piece of code, like here how it has been written, what exactly these codes are doing. So requirements are like you need a simple laptop, you need a basic understanding of Python, PySpark, and SQL queries, like how SQL queries works. And nothing apart, I can say like if you have this type of things like a laptop and the understanding of the programming language and the Spark framework, it is very easy to start with that project. So without wasting the time, let's start. Firstly, before starting or jumping into writing the code, I will just show you like how I have set up the tables and what are the tables we have used and what type of data those tables contain. So let's start. Like I will just show you. So here I have used pgadmin, which is PostgreSQL, and you can use anything, like it's very simple. You can create the table, you can load the data, but you have to use the connection things. It will be a bit different for you. It's different if you are using some different tables or if different database. But for us it's like, so I am just gonna brief about the project. It's like a Mizoram weather details. So Mizoram is a state in India, and like we all know about those things, like that it has a heavy rainfall things and all. So before like jumping into the code part, we will start like writing, and we will writing the code, we will just know like how Mizoram data summary is getting collected in the final output table. So like what we are going to do, we have some table which is like, here you can see this is a place master. I will just show you the column names also. So here place ID, place name, latitude and longitude. For this table we have used Again we will be using this weather readings. So in this columns we have used place id, reading date, temperature, rainfall, humidity. And again for others, like we have used load status. This columns contains load status id, status description, and the other table which is like we have used is a flood alerts. So basically we are collecting the aggregate values for this particular measurum month wise, and we will put it into a table which we have already created into a same server, which is named, as you can see, it is Mizoram weather summary. So here you can see this all aggregate dates we need to calculate based on these four tables. Load status is not a table which will you be used to calculate the data as like an aggregate, but it is a something which will show you the status of the running code of Spark. So here when I will just move into this place id, place name, month, date, average temperature, total rainfall, average humidity, the maximum water level, and the flood risk level, and the load status id. So this information we need to collect into the output table, and from the source which I have recently mentioned as like flood alerts, load status, and others one is like sorry, yeah, weather readings and place master. So these four tables are the source tables from where we are extracting the data, transforming through code, transforming through Pyspark, Python, SQL, and Spark SQL, and then loading into the target table, which is our Mizoram weather summary. So let's start. If you want, I can show you how data are already there. So select a star from flood alerts. I will just show you one thing because it's a time wasting. So you can see here it's like the datas are there, and approximately it has some 2000 5000 records are there. I will just show you the weather readings also. So if we will go with weather, you can see here 5000 records are there. Earlier I have seen like 2000 records. Yeah, so let's start with those scenarios where we have been working in that, and I will just show you like how these structures are working. Okay, before starting I will just take one download folder. Yeah, so here I will just do one thing, folder, and I will mention it as data engineering, or I can say mini ETL, or you can mention it as like data engineering project. Okay, okay, it's already existing, so let's give this as data engineering project. Yeah, now I will just do one thing. I will just open it. Yeah, let's make one folder here, mini ATL project. Yeah, so it's a mini ETL project, and then we will start. So firstly, like as I mentioned, there is a source table, so we need to define the source tables. We will make one JSON file here. I will just make one folder here. I will just firstly maintain the folder structure, and then I will explain like how and what these folder structures will do. So let's start with this. I will make one folder here as config, then let's make one folder as logs again, then make one folder as src. Yeah, so these three basic folders we required to start the project, and these three folders will help you like to know how this whole code structure will run. So without wasting the time, let's start creating the folder file. So under config, as I mentioned, we will make a JSON file which will explain like, so ETL, I will name it as ETL config dot JSON. Yeah, so we'll just start writing the code And as I mentioned, we will define here like, firstly we will define like table structure. Table structure. Place master. So I have given a place master here. Weather readings, flood alerts, load status, and target summary we will take here. So these 5 things we will be taking here, and I will just let you know what exactly we are going to do here. Public dot. So public here is our schema. I can show you. So here you can see this is public, and under this public this table is there. So if you will run this with public dot, it will give the exact data. Yeah, so the same thing it is giving you. If it is, it can give you without also, because you are already under that schema. So here, but we need to here mention it is like what exactly we want to do. So place master, these tables we are gonna use. We all know why we are giving this. Again, weather readings was one of the table. Okay, so yeah, so weather readings public dot. Public dot. I will just copy and paste here. Now we'll move to load status. Sorry. And the last one will be target summary. Which is gonna mean public dot. So here target summary is an alias we have used, which will once we will be using in the JSON. You know like how JSON file works. So from this key we can call this, and again the value will be called here as public dot, where this target summary is being loaded is Mizoram weather summary. So I will just mark it as like Mizoram weather summary. Yeah, so now I'm just gonna do one more thing here. I will define in a same, it will be a nested JSON here. Yeah, so log path, everything I'm gonna tell you like why I have used these things, why I have not used. So I will define my path here. Users, to run the code it is required to define my path, because it is in my local. You need to specify your path here. Just make remember while doing these projects. I will create this ETL. So you have already seen that I have created a logs. Under that I will just create one ETL run dot log. Okay, so now it has been created, just no need to write here. Okay, and again there will be a month date. So here we will define a month date. Let's example whatever the data we have taken, it can define as 05 31. Okay, so now we can see these values has been defined. These are source tables. Another one is target one, which is loading the data into Mizoram weather summary. This is a log path where we can find out the log is being created there. This is a month date for which we are gonna run this. Load status ID is a variable we will be running and loading into the target table. So now everything is clear. It's basic config is done. JSON, yes, ETL run log is created. Now we'll move to the source folder. So what are the files we need to create under the source is like, firstly here we are going to create which is called a database config file. So we all know, like when we are writing the code in Pyspark Python, there needs to connect the data or to load the data from source, we need to connect our Python code to the target table to the table. So how we are going to connect to the table, I'm just gonna write this code for here to just make you a better understanding of all those things. Like, so let's go with that without wasting the time. I will just make one file here which is db underscore config.py. so firstly let us start with this. I'm gonna write this pyspark.sql. Okay, here it's wrong from Pyspark. Yeah, now I will just write you db host. I'm writing it's manually because just to make you understand like where I have and what I have written here. So each and every line of code will make you a better understanding to know the ETL, how ETL works, how the connection works, how the code works, and from where it is getting connected, which variables has been taken, what are the key values pair has been taken from JSON files. That's why I'm writing it manually each and every line of code, else I have already pasted it and just move forward to write the main part of the ETL. Just not because like I'm writing this, because it will make you more interesting how the code works. So db port, I will define here 5432. You can define yours one. So now these are the variables. For me it is ETL db. I will just show you. So you can see this is the database structure I have used, ETL db. So it's an ETL db for me. Now the username I will just define here. User is Postgres itself, and there you need to provide the password. So the password for me is, you have to give your own password. I will just JDBC driver path. For me it's I will just go. Okay, So now I have already defined these labels. For me, this path is present in that folder, and now we can start like def get a Spark session. I'm just giving here my app name. You can give yours one, it's not a problem here. I'm just calling it as like Postgre Pyspark connection. And here I'm just gonna write down those who know like how to get these things, they will be able to understand like what this app name and dot get builder dot get create will do in a Spark. This is the part of like the code config spark.jars. Driver path we need to give here, and now we will just get or create. So it will create a Spark session now. Now I will just write down here return a Spark. So it will return the Spark value we have defined in the that function. Okay, now we'll create one more function, get JDBC URL. So here return JDBC. Okay, I have done one mistake. I need to give this one. Under this it need to be defined here now. So let's move here. Now we will create one function to read the table. So I am here defining mode as an append. Why? Because when we are writing into a table, there might be a chance that the duplicate data might got loaded. So you can define the mode here if you want to. If you don't want to load the same data, you can define it as overwrite. Append means like it will load append the data whenever the new data will come. It will append the data into the same table. URL, and then we will write down df.write dot format. It will be almost same as like red, but there is a minor difference here. Option, I'm just gonna copy and paste this part because till here it is same. And now dot mode mode dot save. Okay, so this part of config file is ready. Now we'll move to the next section of the code, which is like data quality, like how we are defining the quality of the data. So that we are also going to write down under the same src folder. I will make data quality.py. Okay, let's start writing the code here. It will be same for this. I'm just gonna copy and paste here. Okay, yeah, let's start with firstly, like for data quality, what exactly when we are dealing with these tables, there are lots of nulls values, there are lots of like missing values, and to check the row count, these all things are like comes under data quality. So we will create here a function and we will call in our main ETL code where it will work as like the data quality checks. Columns logger. So for in columns function has been created. Now we'll just go with def check row count. Okay, here I have done one mistake. It should go like that, yeah. Actual count, and now I will actual count is equal to actual count less than expected count, expected minimum. Logger dot warning. So this function will take, now we will so this one we have created. Why it has given as an hello, let's see. Okay, there is something it is checking to py. Okay, from SQL dot functions import cool. So now it will not give you error. Yeah, the Spark session here we need not to give. Now this has been written done. So let's move to the logger part. We are using logger here, but I will just tell you like what exactly this is gonna do. Import logging from config parser, import config parser. We'll create one function, get logger log file. So here we have set the label. Now logging. one is also completed. We'll just save this, and now this is the final thing we are just gonna do here under this. I will create ETL job.py. Yeah, so in this code part of code we are just gonna write like how we have used the, or how we have initialized the ETL transformation, ETL process. So let's start. So everything is now set up. We know like this data quality db config ETL job logger. So ETL job we are gonna write it. Data config is already set up here. Okay, it's fine. Yeah. Let's jump to this part. Logger is also written. ETL job we will write. ETL run log will just generate. Config is already here. Okay, we'll just cut it. Yeah, save. And ETL db config is also there. Yeah, we'll just write ETL job here.